Hello, everyone. Thanks for the conference committee's kind invitation. Today, I'm going to introduce you something about human-object interaction understanding. Human-object interaction requires to understand the relationship between human and object. This means we need to answer the following questions. What's the relationship between a particular person and the surrounding objects in the present we are seeing? Where are the human and objects, and how the person is interacting with these objects? For example, how to localize the person and the book in the left image and recognize the interaction, read the book. In the right figure, flying a cat, HOI understanding requires to localize who is interacting with which cat, which is usually very challenging. Moreover, for human being, understanding HOI interaction requires not only perceiving capability, such as object localization, but also cognitive capability, such as reasoning the relationship between human and objects. Therefore, HOI understanding is an important task for us to design reasoning methods and evaluating the reasoning methods, and therefore achieve human-level cognitive capability. Current HOI approaches can be categorized into HOI recognition, detection, video-based understanding, and other HOI understanding tasks. HOI recognition aiming to recognize the interaction in a visual scene have attracted intensive interest from the community, such as some researchers utilize the pose estimation and human power segmentation to facilitate HOI recognition. Currently, HOI detection is an increasingly popular challenge. Human-object interaction detection targets at localizing human and objects in images, and meanwhile inferring the relationship between human and the surrounding objects. With the development of transformer-based detection methods, current HOI detection approaches have achieved a significant improvement. Video-based HOI understanding is also an important task for HOI understanding. Some kinds of HOIs, such as pull the bottle and push the bottle, are difficult to recognize according to the statistical images. Those HOIs require excellent temporal information learning. Therefore, many approaches study HOI from videos. However, it is usually time-consuming to process the video. The resource requirements of video understanding limit the progress of video-based HOI. Meanwhile, there are a few video HOI datasets. Moreover, HOI is closely related to other tasks, such as action recognition, human pose estimation, object affordance recognition, 3D reconstruction. As a result, there are many HOI approaches to explore the importance of HOI on other tasks, or learn to understand HOI and other tasks in an end-to-end fashion. For example, some researchers utilize the interaction information for human 3D reconstruction. We pioneered to illustrate the possibility for object affordance recognition with HOI model via affordance transfer learning. The exploration of the HOI and other tasks is a promising direction. We think there will be more opportunities on the exploration of HOI and other tasks. HOI has a close relationship to action understanding and visual relationship understanding. On one hand, HOI is closely associated with action understanding. Action understanding contains pose recognition, such as standing, running, and human-object interaction. In our daily life, action usually involves various kinds of objects, such as play football. That is, human-object relation interaction. HOI can significantly facilitate action recognition because the surrounding objects of the person provide informative context For example, without the object football, it is difficult to distinguish playing football from running because human poses are very similar. However, with the football, it is easy to distinguish playing football and running. On the other hand, actual eye is a kind of real relationship, such as football in nets, that is scoring. Real relationship targets it is the relationships among objects. Each relationship is composed of the triplet, subject, predicate, and object. Compared to real relationship, actual eye, person, verbal, and object can be decomposed into a pair, verbal object. That is, the subject in the actual eye is fixed to person. Actual eye has more application scenarios, such as superstores, compared to object relationship, because we care more about human-centric relationships. Furthermore, object is an important factor of actual eye. When we observe an actual eye sample, such as playing football, we can directly infer the object is playable. This indicates the affordances attributes of the football. Therefore, actual eye is also valuable for object understanding. On one hand, actual eye provides the information of semantic affordance of the object, that is, what actions can be applied to the object, such as kick the object. Moreover, actual eye also illustrates how to play football. For example, which part of our body can kick the football? This is useful for robot to learn how to operate the objects. For example, we can use actual eye sample to teach robot to play football. It is important for imitation learning. Besides, actual eye is also helpful for small object localization and occluded objects. Small objects are easily ignored by most object detectors. However, actual eye provides a useful clue for the localization of the interacting objects. For example, we can localize the football according to the pose of the player. We provide further evidence to illustrate the importance of actual eye for action recognition. Here is the AI 2021 report from Stanford. This report illustrates the most difficult actions for understanding. We can find the challenges of activity detection. This mainly comes from human-object interactions, such as drinking coffee, polishing furniture, removing colors. This shows the significance of actual eye for action understanding. Once we understand the human-object interaction appropriately, we can largely improve the performance for action recognition and action detection. Here is the statistical results of object occurrence in viral genome dataset. We can find man, person, woman are the most frequent objects in viral genome. That is, in our daily life, the viral relationship is usually human-centric. This illustrates the importance of actual eye for viral relationship understanding. Overall, the most challenging thing in action recognition or detection and viral relationship understanding is actual eye. We believe actual eye understanding will largely facilitate action recognition and viral relationship understanding. Here, I'd like to introduce the history and progress of actual eye. In 2007, with the development of action understanding, researchers found the surrounding objects can facilitate the recognition of action. Gupta introduced an approach to understand actions and perceive objects in a joint way. Specifically, they presented a Bayesian approach to integrate information from scene analysis, pose estimation, object context, and reaction, where applying spatial and functional constraints. Since then, actual eye gradually becomes an independent task and attracts increasing interest from the community. From 2010 to 2015, Many HOI approaches based on traditional methods were proposed. Yao and his colleagues introduced a people playing musical instrument dataset and presented a sequence of work for improving HOI recognition from pose, parts, and spatial perspective. For example, they utilize a structure search approach to estimate the connectivity between objects, human pose, and different body parts for recognizing object and estimating human pose jointly. Chao and his colleagues introduced the HICO and HICO-DAT dataset for HOI recognition in 2015 and HOI detection in 2018 separately. The two large datasets contribute large benchmarks. HICO-DAT offers more than 150,000 annotated instances of HOI pairs, with 600 HOI categories in HICO, include 117 verbal categories and 80 object categories. Based on those HOI datasets, many HOI recognition and detection approaches have been proposed and achieved significant progress. Well, many approaches focus on action understanding from a pose, body part, and segmentation information for action understanding. Cato and Gupta proposed a compositional approach for HOI recognition in ECCV 2018. They use external knowledge graph and graph convolutional networks to compose verbal noun pairs for zero-shot HOI recognition. However, external knowledge limits the scalability. Differently, we proposed a new visual compositional learning framework termed as VCL to compose HOIs between image pairs to address the long-tailed and zero-shot issues on HOI detection in ECCV 2020. In CVPR 2020, Liao and his colleagues proposed a single-stage human-object interaction detection method with real-time inference based on point detection methods. Specifically, a point matching branch is proposed to match human and object points. This real-time HOI method facilitates the application in industry. In CVPR 2021, Masato and his colleagues introduced a query-based pairwise human-object interaction detection based on transformer. Specifically, each query in the method is designed to capture one whole of a human-object pair rather than human or object instance. This provides new insights for HOI detection. Transformer-based methods largely improve the performance on HICO-DAT and VCOCO by leveraging image-wide features and global context. Those transformer-based HOI detection methods build a milestone on HOI detection. At the same time, we present an affordance transfer learning framework for HOI detection and object affordance recognition with HOI model. We present a way to exploit a broader source of data for HOI detection, and meanwhile incorporate HOI detection network with decomposed affordances to infer the affordance of novel objects. Interaction can be regarded as a human perspective of HOI, where affordance is an object perspective of HOI. Affordance transfer learning constructs a new bridge between HOI and object understanding. We further illustrate the number of accepted HOI papers in recent top conferences. Here, we search the papers in the paper list in those conferences via the keyword human object. We can find the number of accepted HOI papers is gradually increasing, which means the interest from the community on HOI is increasing. In recent years, HOI understanding has achieved an impressive progress. Human-object interaction has a wide range of application scenarios. The most common application scenarios are shopping malls and stores. Modern intelligent systems in the shopping malls or stores require to understand the behaviors of customers. Then the shopping mall or the store can make some recommendations for the customer or delineate reasonable commodity zoning and thus provide better service for customers. A customer in the store usually interacts with various kinds of goods with different size and color in the store. For example, watches the beverage, picks up the beverage, and pushes a shopping cart. Understanding the interactions with the goods in the store is an important way to understand actions in the store. HOI can also be applied to player motion analysis. In sports field, there are many interactions between player and the ball. For example, throw the ball, catch the ball, swing baseball bat, strike the ball, hold teammate, and so on. Modern sports teams usually include an expert video analyst to analyze the interaction between a player and the ball. HOI understanding between player and the ball can provide suggestions for the player to improve their skills, and meanwhile help the coaching team to improve the tactics. Here, we introduce the challenges of HOI. There are some important challenges in HOI, include data, recognition, localization, and efficiency. First of all, current deep learning methods rely on a large number of training data for network training. However, it is time-consuming and resource-consuming to collect HOI data. Meanwhile, a large number of HOI data forms a long-tailed distribution. As a result, the model usually tends to predict the frequent HOI categories while ignoring rare HOIs. Meanwhile, it is difficult to collect the instances of rare HOI categories in nature or our daily life. Therefore, we should address another important challenge: zero-shot HOI detection or recognition. Label missing problem is also an important challenge in viewer relationship tasks. On one hand, the annotation workers have their own preferences. Thus, the annotation workers might label out some kinds of HOI labels, while ignoring other HOI samples in the image. On the other hand, people usually ignore the small objects people in the image when they are annotating the relationships. Second, human-object relationship recognition is also difficult. Current deep learning models usually discriminate different categories via appearance. However, when we interact with glass, such as drink with glass and smell the glass, the appearance is usually very similar. In HOI detection, there is also a verbal polysemy problem. That is, the same verbal might have different meanings. For example, hold the book is largely different from hold the elephant. This poses an important challenge for verbal recognition. Meanwhile, people usually reason the interaction via the global relationships among context and object in the scene. However, how to model the interaction object graph in your scene is still very challenging. Temporal information learning is thus important for human-object interaction understanding, but video processing is usually time-consuming and resource-consuming, which poses a great challenge for video-based HOI understanding, such as video HOI localization and recognition. Third, localization is also an important challenge. Object localization is the first step for HOI detection. Modern object detectors usually fail to detect small objects in the scene. Currently, HOI approaches, especially human-object interaction detection, are usually based on object detectors, such as fast RCNN detection with transformer. As a result, the HOI approaches easily fail to recognize detect HOIs related to small objects. Besides, localizing the interaction is challenging. That is, we need to know which objects are interacting by the person. In some things, such as flying a cat, the person is usually far away from the objects. Besides, when there are multiple similar objects, it is also difficult to localize the interaction region. Last but not least, the efficiency of the network is significant for the application of HOI methods. Current HOI detection approaches can be categorized into one-stage HOI detection and two-stage detection. Two-stage detection methods localize objects and recognize the interaction separately, while one-stage HOI detection conducts object detection and interaction recognition jointly. Two-stage HOI detection approaches are usually less efficient and thus is not much applicable in practice. One-stage HOI detection methods are usually efficient. However, how to maintain fast inference speed and meanwhile improve the performance is challenging. Then we begin to introduce some kinds of challenges in detail, and meanwhile illustrate our proposed approaches for these challenges. There is a serious long-tailed issue in HOI detection. Many types of HOI categories form a long-tailed distribution. For example, in HICODAT, the most frequent type of HOI has over 4,000 instances, while a large number of HOI categories have only less than 10 instances. This poses a great challenge for HOI detection. Meanwhile, we also need to address zero-shot challenge for HOI detection. Nonetheless, HOI has obvious compositionality. We thus propose a series of work to address the long-tailed, few-shot, and zero-shot issues via compositional learning. Human-object interaction has an obvious compositionality. That is, HOI can be decomposed into verbal and object, such as read and object. Different from other compositional tasks, the factors such as verbal and object in HOI can be decomposed according to bounding boxes. As a result, we can focus on the compositional learning. First of all, we present a visual compositional learning framework to address the long-tailed and zero-shot challenge in HOI detection. The proposed visual compositional learning framework first decomposes the verbals and objects from pairwise HOI images, and then composes novel HOI samples between the decomposed factors from the two images. The composite HOI samples effectively relieve the long-tailed and zero-shot issue. This visual compositional learning framework is published at IJCAI 2020. Though visual compositional learning achieves important improvement, we further notice that the long-tailed HOI distribution mainly comes from the long-tailed verbal object distribution. As a result, the composite HOIs in visual compositional learning might be also long-tailed, which degrades the performance. Inspired by the success of feature generation for recognition, we propose a fabricator to fabricate object representations. Specifically, we fabricate balanced objects for each verbal in mini-batch, and thus effectively ease the long-tailed, few-shot, and zero-shot issues. The fabricated compositional learning approaches has been accepted in CVPR 2021. Furthermore, we notice it is challenging for the fabricate real objects. Meanwhile, a straightforward question comes out. Since we can compose HOI samples from fabricated objects and verbals, can we compose HOI samples from real objects and verbals, such as objects from object detection dataset? The answer is positive. Meanwhile, this can effectively ease the issue of fabricating unreal objects. Therefore, we propose an affordance transfer learning framework to utilize a broader source of data for HOI detection, especially for novel object HOI detection. Moreover, The affordance transfer learning framework also enables the object affordance recognition with HOI model, where transfer the affordance representation to novel objects. This work has been accepted by CVPR 2021 as well. Well, many samples in images are small and are easily ignored. Meanwhile, everyone has their own bias. Therefore, the annotation labels might miss labeling some samples. For example, the person in the red rectangle might be ignored by annotation labels. As a result, the model trained with those data might bias to obvious instances while ignoring unobvious instances. To address the label missing problem and make use of unlabeled data, we propose a novel multitask compositional network, which includes a significant submodule to discriminate the significance of the relation samples. And then is the label missing challenging and meanwhile improve relation detection. In detail, we design a relationship generator to generate undetermined relationships and utilize the undetermined relationships and the determinate relationships to optimize the significance submodule. HOI also faces recognition challenges. On one hand, the diversity of the same categories might be very large, such as hold the book and hold the elephant. This poses a great challenge for verbal recognition. Current deep network approaches usually require massive samples to ease the diversity of the same categories. However, it is also difficult to collect HOI data. On the other hand, some different HOIs might share similar characteristics. For example, nose glass and drink with glass. The difference between the two categories is usually small. The main difference between nose glass and drink with glass is the relative position between the glass and mouth. However, the characteristic is not obvious, and the two categories are very similar. This requires to utilize spatial positional relationship understanding between human and objects. In order to ease the verbal polysemy issue in HOI detection and improve the recognition of verbal, we leverage additional features, such as spatial feature, pose feature, and language features, to design a polysemy deciphering network with the pose information and language representation. The polysemy deciphering network largely improves the verbal recognition for HOI detection. Specifically, the newly designed network introduces several modules, include language prior guided channel attention, language prior based feature augmentation, and polysemy aware model fusion to obtain polysemy aware features, and thus ease the verbal polysemy problem. Localizing small objects is difficult. Current methods propose to utilize interaction clues to localize small objects. However, small object detection is still an important challenge on detection-related tasks. Besides, it is also difficult to localize interaction. When we detect the objects and human, it is difficult to judge which object is interacted with the person. For example, in the right figure, there are two people fly two cats. Although we can easily localize the people and the cats, which cat is interacted by which person is hard to localize. Recent works have revealed that the eyes of human beings usually move around the object to discover more cues regarding its location. Similarly, when it comes to HOI detection, people often first glance at the scene to identify possible human-object pairs with any interaction. They then search for cues around each pair and finally gaze at discriminative areas to identify the interaction class. Accordingly, inspired by the above observation, we herein propose a novel model named Glance and Gaze Network. to localize informative areas for the interaction between the human-object pair. The proposed method adaptively infers a set of action-aware points to represent the interaction area. Given limited time, here I'd like to conclude my speech. IJCAI has increasingly attracted intensive interest from the community. IJCAI is important for action understanding and visual relationship reasoning. Furthermore, IJCAI also provides strong clues for object localization and understanding. There are many challenges for IJCAI understanding to be conquered. To address those challenges, we have delivered a sequence of approaches in the past years. I hope they are useful for your specific tasks or as baselines for your future research. Thank you for your attention.